Today we're going to start talking about polynomials. So we first need a definition of what a polynomial is. So the definition we're going to use is that a polynomial is the sum of a finite number of terms of the form a times x to the n, where a is a real number and n is a positive integer. So let's take that definition apart a little bit. So the sum of a finite number of terms, and by sum we could be summing negative terms, so that's going to mean terms that are either getting added or terms that are getting subtracted from one another. Finite means that it's a specific number, so these are not terms that never end, which is a type of problem you'll see in higher math classes, but not in this one. So a specific number of terms, and they are all of the form a times x to the n. And sometimes that x is to the 0 power, and if you'll remember back from our exponents unit, when x is to the 0 power, that's the same thing as 1. So those terms are going to be made up of only real numbers, or terms that back when we were in our linear chapter we talked about those being the coefficient or the constant. So we call that number out in front of the x a coefficient if there is an x attached to it or a variable attached, or a constant if there's not an x attached. What's going to look different in this unit from our linear ones is that now our variables are going to have exponents on them. But we have some rules around that too, that our exponents have to be positive integers, so they need to be whole numbers. You can't have an exponent that has a fraction or a decimal in it, or that has a negative sign. If we did, it would be called a different type of problem, not a polynomial. So there are some specific types of polynomials that get their own special names. A monomial has just one term. So some examples of those would be things like y squared, or negative 4t to the 5th, or just a plain x, m cubed n squared, negative 3. All of those are examples of monomials. So you can see that they all fit this a times x to the n form. In this one, our a is a 1, and our n is a 2. Here our a is a negative 4, so when you see this in a string it's going to look like subtraction, but we'll be adding a negative 4 t to the 5th. This one has an x where n is a 1 and its a is also a 1. Here a is 1 again, and you'll see that sometimes these terms have more than one variable in them, and that those variables may also have exponents on it. As long as there's no addition or subtraction in between the variable terms, they're still considered part of the same term. And then negative 3 is one that I was talking about that has that invisible x to the 0 power. When you raise x to the 0, it becomes a 1. Multiplying that by negative 3 is still going to leave us with just negative 3. The next set that we're going to look at are binomials. Binomials have two terms. So if we take any of these other terms that we had and we connect them with an addition sign, it becomes a binomial. So some examples for that might be w plus 2, or 4z squared minus 11, maybe a to the 4th plus b to the 4th, or a really big one, negative a c to the 3rd d to the 2nd plus 3cd. Any of those are binomials because w is a term, 2 is a term, they're connected by addition. 4z to the second is a term, negative 11 is a term, they are connected by this invisible addition here. And then our last one, if you haven't already seen the pattern here, after binomial, which means 2, is trinomial, which means 3. So trinomials have 3 terms. And some examples of those would be things like x squared minus 3x minus 40, or 2q to the 4th minus 18q squared plus 10q. 4 terms or 3 terms there as well, so that fits the definition of trinomial. And then one nice big long one here. How about 6a to the 4th plus 29a squared b plus 28b squared. The next thing we want to look at are some attributes that polynomials have. So because our terms now have exponents in them, we're going to have a way of defining each of these terms that we call the degree of a term. So the degree of a term is the exponent on the variable, okay, or if there is more than one variable in the term, the sum of the exponents. If more than one variable. So you'd add them up. So if we look at just a couple of the examples up here that we were doing before, y squared would have a degree of 2. Negative 4t to the 5th has a degree of 5. X has a degree of 1. M to the 3rd, n to the 2nd, we're going to add the exponents together. So this has a degree of 5. And negative 3 has a degree of 0. Because remember our example was that there is really an invisible x multiplied by that 3. It's just raised to the power of 0, so it turns into a 1. The next thing that we want to talk about, so terms, individual terms can have a degree. A polynomial can also have a degree. And we define the degree of the polynomial as the highest degree of any non-zero term. Okay? And I think I'm going to wait till we get into some examples to describe what this non-zero means. So for now, just think of it as the highest degree of any of the terms within that polynomial. So if we're looking at this binomial here, w has a degree of 1, 2 has a degree of 0, so the highest one in that one is a 1. Here, the z squared is going to give this polynomial a degree of 2. This one, this term has a degree of 4, this term also has a degree of 4. So we don't add them, it's just the highest degree of any one of the individual terms. So this one wouldn't have a degree of 8, it would just have a degree of 4. Over here, though, within this individual term, we have a c cubed d to the d squared, so that the degree of this polynomial of negative 8 c cubed d squared plus 3cd is going to be a degree of 5.